Machine learning is the driving force behind artificial intelligence, and it's one of the most important things that you can learn. In this video, I'll go through and explain the three main types of machine learning, that being reinforcement learning, supervised learning, and unsupervised learning. We'll also quickly touch on the fourth type, which is an in-between called semi-supervised learning. However, I'm going to explain it in a very simple and intuitive manner rather than just spamming through definitions and PowerPoint slides. We'll start at the top with this idea of machine learning. All machine learning is attempting to do is to get a machine to learn from data. And an easy way to understand machine learning and the subtypes of machine learning is to liken it to how humans learn. Because we humans also learn from data, because all data is information. And so if you think about how we learn everything through our experiences, from the day we're born to the day we die. Maybe they're experiences at university or just experiences riding a bike or whatever it is. We learn through experiences, which is just another form of information or just data. And so just like how we try and get machines to learn from data, us humans also learn from data. And so if we think about all the different ways that we've learned things throughout our lives, you can categorize it into two types. The first category is the kind of things that we learn with feedback. So maybe this is your teacher telling you what the correct answer is, or you trying to say do something, maybe ride a bike, and failing to do so. All of these are you getting feedback on how well you're doing something. And we can group these kinds of feedback into two categories. The first kind is that kind where you're being told what the right answer is. Maybe it's your teacher telling you what the correct answer is. And one example I like to use here, which I'll use for all the different types of machine learning, is imagine you're trying to organize books. But in this case, maybe your manager has told you have to group these books into either fiction or non-fiction books. Well, in this case, you'd have to learn how do you categorize into fiction and non-fiction. And so maybe your manager would sit down with you and give you a couple examples of books that are fiction and books that are non-fiction. And then once you've learned what's fiction and what's non-fiction, you can then go out and categorize all of the other books. And so in other words, you're learning by being instructed or being told what the correct answer is. And what this is usually referred to in the realm of machine learning is labeled data, because you have data, maybe it's the book, all it is a piece of data, and it will be labeled as either fiction or non-fiction. And then through some of this labeled data, all these books that you've been told that are fiction or non-fiction, you'll learn how to differentiate between the two categories. So you can then go categorize unlabeled books that you've never seen before. And so the goal with this kind of learning is to answer it correctly. And this is a very common kind of learning that us humans experience throughout our education, where there is a set answer and we're trying to learn how to answer it correctly while we're being supervised by our teacher. And so we call this kind of learning supervised learning. It's learning with instruction. It's learning from labeled data where you've been told the answer. And the ultimate goal of supervised learning is to figure out how to answer these questions correctly with data that you've never seen before, maybe with books that you don't know if they're fiction or non-fiction. And so that's the first kind of way that we can learn. And that is by being told, by being supervised by someone else and them telling us what the correct answer is for a small subset of examples. However, another way to learn through feedback is by learning from the consequences of our actions. Maybe we're not being told what the correct answer is, but instead we have a set goal in mind. If we use a similar analogy to sorting the books, maybe we're now trying to organize books, but our manager hasn't specifically said organize them into non-fiction and fiction. Instead, now we're just trying to organize them in a way that maximizes the sales. So we have a goal in mind. We haven't been told what the right answer is, but we have been told what the goal is. And so now we will be learning by how well we're accomplishing that goal. Maybe we get our input data, all of these different books, and we can sort them into various different ways, maybe by genre, alphabetical color, put them in different places in the shop, whatever it is. But then that action of sorting it will then lead to a number of sales. And that is what determines how we learn, because then we look at the number of sales and we use that to refine how well we sorted those books. And so we're learning from the consequences of our actions. So you're not given any instructions. There's no correct output, but instead you're learning by the consequences of your actions to achieve a given goal. And this is a kind of learning called reinforcement learning. Other examples that you would have experienced in your day-to-day life are riding a bike, where when you first learn to ride a bike, you'll take a given action, maybe that's sharply turning the handlebars, and that'll then have a consequence. In this case, maybe you fall. And so then you would learn from that consequence of your actions that, okay, when I sharply turn my handlebars, I fall. And so then you would learn to not sharply turn your handlebars. So we're learning through those consequences. Another really good example to understand some of the lingo that we use in this subset of machine learning is to think of a rat trying to navigate a maze. In this case, the rat will start in a given state. It'll then take a given action. Maybe it goes down this passageway over here. And in this case, it would then find a little bit of cheese and be rewarded. And so it would learn that that action is good. And then it would continue to take another action. Maybe it comes up here, and then maybe it would get a reward or maybe not. And so it's continuously taking actions, changing its state, in this case, its position, and occasionally getting rewarded. And so one way we can sort of denote this in a diagram setting that you'll usually see in reinforcement learning is you'll have a given agent. In this case, it's the mouse. And they'll take an action, in this case, moving in its environment, and then that environment will slightly change. It'll, number one, change its state, where in this case, it's changing its location, and occasionally it'll also change its reward. Sometimes it'll get a reward, sometimes it won't. But it's this idea of an agent that takes an action, and then that results in a change in state and a potential reward as well. And then we feed that back in, and then the agent learns how its actions are leading to these different rewards. And so that's the second kind of machine learning, reinforcement learning, where you're learning through reinforcement, where you're learning from your actions, where a good action will be reinforced as good by getting a reward, and a bad action reinforced as bad by getting a negative or a punishment. And so those are the first two kinds of machine learning. However, if you think about humans, we don't only learn things with external feedback. We can also learn without any feedback at all. An example of this is how humans learn facial expressions. We're never explicitly told what a smile is when we're younger, but we pick up positive facial expressions and negative facial expressions. And an example with the running theme of organizing books is maybe you have to organize books, but once again, you have no instructions. You're not told what the correct organization is. In this case, all you're doing is finding patterns. You're learning patterns from the data, all these different books you're given. You learn these patterns and maybe you group them by genre, by alphabetical, or by color. And through this process, you're not being told what the correct answer is. In other words, your data is unlabeled. The input data you've been given doesn't have a label of what the correct output would be. And you have no instructions. And so the output can be whatever you want. And so the goal here is purely just to find patterns within that data, not to explicitly get a correct answer. And so this is what we call unsupervised learning, because you're learning without the supervision of someone telling you what is correct and what is incorrect. And the final kind of machine learning is actually a combination of two others. And that is semi-supervised learning, where it's semi-supervised. Some of its learning is through a supervised setting and some of it through an unsupervised setting. And semi-supervised learning has a very similar goal to supervised, where we've been given a task, maybe it's organizing books with a clear goal, a clear correct answer. And so our goal here is just to answer correctly, to say correctly categorize books into either fiction or non-fiction. So just like supervised learning, in semi-supervised learning, we would start by looking at the labeled data we've been given. Maybe it's the books that we've been told are fiction and non-fiction, and then learning to categorize them into those categories using those examples. So we'd go through, we'd learn, and we'd try our best at categorizing into fiction and non-fiction. But the issue is maybe we didn't have much training data. We didn't really have many examples of fiction and non-fiction. And so when we were grouping, it was a bit dodgy. We weren't the best at actually differentiating between the two. And so what we can do is we can actually use some of the power of unsupervised learning. Because maybe we only had a small amount of training data, a small number of examples of if a book is fiction or non-fiction. But we have tons of other books. All of the other books we're trying to categorize is effectively unlabeled data. It's books that we don't really know if it's a fiction or non-fiction. And so just like in unsupervised learning, we can look at that data and then we can try and find underlying patterns. Maybe we find the pattern that every author usually only writes fiction or non-fiction. Well, we can then use that pattern to question our initial decision. So we made that initial decision with our supervised learning that, oh, this book is fiction. But then we notice that there's a pattern that authors usually only write one category. And so then we look at this author's books and we notice that, oh, 9 out of the 10 of this guy's books are nonfiction, but I've categorized the 10th one as fiction. And so then we start to question, oh, maybe that's incorrect, because this pattern is telling me that it's probably going to be nonfiction actually, because they usually write the same kind of book type. And so what's happening here is we're using this unlabeled data to actually identify patterns. We're using the same processes in unsupervised learning to identify these patterns, and then we can use these patterns to start to question our initial categorization that we used with purely supervised learning. And so those are the 4 types of machine learning. And you see, if you really drill into them, they're actually incredibly simple and you can understand them intuitively. So whenever you're learning machine learning, don't just focus on memorizing definitions and don't get lost in maybe tons of PowerPoint slides. Try and understand it intuitively. And if you want to continue to watch more videos intuitively understanding the topics of machine learning and AI, feel free to subscribe, because I'll be making a lot more of these videos to come.